Everyone, welcome to the Student the Brand. So today I'm going to discuss about human eye colorful world. So in human eye colorful world, in the previous live class, I explained about side effects, so myopia, hypermetropia. Okay, but we discussed human eye parts also. Now in this class, so we are going to discuss about refraction through prism. Refraction through prism will discuss. So how it will be there. So when light passes through the when light is passing through the prism, how the refraction takes place, everything we will discuss now. So be ready. So if you have any doubts, you can ask. So we'll work out on it if you have any doubts regarding the. Okay. So now I will work out on. We can see now. So we are going to discuss about refraction through glass slab. Refraction through glass slab completed, right? So in the it will be so that will be coming in refraction of light. Now prism we will discuss. Okay, so prism I'll explain. Refraction through prism, refraction through prism, refraction through prism will discuss, right? Yes. So refraction through prism I'll explain. So normally if you are considering when the light is passing, when the light is inciding on it, when the light ray is inciding on it, okay, or when the light ray is passing through the prism, when the light ray is passing through the prism, refraction of light takes place. Refraction of light takes place. Okay, so refraction of light takes place. So when it is passing, along with the refraction, splitting of light also takes place. Splitting of light into 7 colors. Splitting of light into 7 colors. So that is nothing but dispersion. Splitting of white light into 7 colors is known as dispersion. So dispersion, right? So now we can see. We are going to discuss about that one. So I am placing here. So this is the prism. This is the prism. This is the prism. Okay. So while I am taking the light ray, so this is the incident ray. This is the incident ray. This is incident ray. Incident ray I am taking. So after that, so it will dispersion of light takes place. Dispersion of light. So 1, 2, 3, 4, 5, 6, 7. Okay. So here this initial direction of the incident ray. I am taking this incident. This is the direction of the incident ray. That's the direction of the incident ray. Okay. So now I am considering like this. So here this is incident ray. This is the incident ray, and here, so after passing through the prism, it's split into 7 colors. It's split into 7 colors. It's split into 7 colors, right? So there is nothing but here it will come out like this, and here also, here also, here also, here like this. So those 7 colors will form like a band on the screen, like this. So those are violet, indigo, blue, green, yellow, orange, red with GR. Okay, so it will split into violet, indigo, blue, green, yellow, orange, red. So these 7 colors, it forms on the screen. So this is the screen. It forms on the screen. 7 colors. So 7 colors will form. 7 colors will form. Okay, so like that is like a Vibgr formation. So we can take the Vibgr formation. So splitting of white light into 7 colors. Splitting of white light into 7 colors is known as dispersion. The splitting of white light into 7 colors is known as dispersion. those 7 colors will form like a band on the screen. Those 7 colors will form like a band on the screen. So band is called, this band is called spectrum. This band is called spectrum. I'm taking here, you can see. So this band is called spectrum. Okay, spectrum. And here, so the splitting of white light into 7 constant colors. So it's split into 7 constant colors. So that is nothing but so what is that one? Dispersion. Splitting of white light into its 7 colors is known as dispersion. Splitting of white light into its 7 colors is known as dispersion. So this is the dispersion. Here dispersion is taking place, and those 7 colors will form like a band on the screen. These 7 colors will form like a band on the screen. So that band is called spectrum. That band is called spectrum. See, so it is a prism. This is a prism. So light is passing. It's split into 7 colors. 7 colors. So we can observe violet, indigo, blue, green, yellow, orange, red. So based on wavelength, based on refractive index. Okay. So based on this all points, so the refraction of light takes place. Once again, so based on wavelength, based on refractive index, okay. So under deviation also, it depends on deviation. So based on deviation, it's okay. So the deviation of light takes place. Now we are going with the recombination of spectrum of white light. 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 So we are going with the recombination of spectrum of white light. So when you are taking, okay, so I'm considering like this. So this is the prism, one prism, and one more prism I'm taking like this here. One more prism. So this is a prism. So Newton is placed normally. So previous one I said, right. So when light passes through that, it's split into 7 colors. It's split into 7 colors. So here what he did, so after dispersion again, so if further you want to split the colors, that's why he placed normal prism. So he placed a normal prism, he didn't get anything. So Newton didn't get anything. So then what he did? So then he placed the prism in the form of like this. So he placed in the inverted position. So like this he placed. Then we got like that. So we got like this. So I'm considering. So here you can see this is the white light. This is the white light I'm taking. So after splitting, of white light. See here. So then we'll get a white light. So once again, draw the diagram. Just check once. Here this is the screen white light. So prism 1, this is prism 2. Okay, so violet, red, white light on the screen. Okay, so you can see, observe. So when white light is passing through the prism, the white light is passing through the prism. So after that, here, so you can see it's passing through it. It's passing through it. So it's split into 7 colors. So this light ray is split into 7 colors. Again, those 7 colors will be passing over another prism. So second prism. So over second prism. So then this will be combined, because inverted prism it will be combined, and so here we can get the white light. So this is very important for 3 marks question. So 3 marks. So very important 3 marks question. Make sure that you are practicing this one. So when light ray is passing through the prism, so it's split into 7 colors. Those 7 colors again fall incident on the, say, inverted prism placed nearby the first prism. Then it will converge all the light rays. Again we will get the white light on the screen. So this is the recombination of spectrum of white light. So in the exam they will ask about recombination of spectrum of white light. Recombination of spectrum of white light. Recombination of recombination of recombination of spectrum of white light. Spectrum of white light. So clear? So this is about recombination of spectrum of white light. Then we can go to the next one. Next topic is, so we'll go to the water droplet, rainbow formation. So rainbow formation, we'll discuss rainbow formation. So here rainbow formation is nothing but when the light ray falls on, see, each and every water droplet. So each and every water droplet, it act as a prism. Each and every water droplet act as a prism. So we are considering now. So I'm placing water droplet. So we'll see how it will be there. So now you can check. So I'm taking the water droplet. So this is a water droplet. So light is incidenting on it. It's split into 7 colors. Okay. So this is a white light. Whichever the light is falling on it. So this white light I'm taking. Okay. This is white light. Now you can see this violet, red. This is violet and red. So what is the phenomenon involved in it? Refraction, dispersion, so internal reflection. So what is the phenomena involved in the formation of rainbow is refraction, dispersion, internal reflection. So you can observe here. So I'm taking like this. So when light ray is coming like this, it's incident on it. So it will be reflected back. So dispersion takes place at this point. Dispersion takes place at this point. Okay, so it's split into 7 colors. Again, it will come out. So here, what is the phenomenon involved in it? Refraction, dispersion, and internal reflection. Internal reflection means actually it is a transparent medium. Some of the light will be absorbed. Some of the light will be okay. So passes through it. Some of it will be reflected back. So that's why we are taking. So internal reflection takes place. Clear? Any doubts? If you have any doubts, you can ask. So you can comment in the comment section. So then we'll go to the scattering of light. Scattering of light is nothing but the The re-emission of light in different directions with a different intensity is called scattering of light. Re-emission of light in different directions with a different intensity is called re-emission of light in different directions with a different intensity. Clear? Shall I? Okay, done. So live class will be there. So you can check once. Live class will be every day at 9 p.m. Scattering of light. I'll tell one thing. So in brief explanation, I'll explain. So just check once. So a light ray is here. I'm taking the wavelength. Wavelength. Here I'm considering wavelength. So here I'm considering here. So this is the wavelength. Live 9 p.m. every day at 9 p.m. you have live class. Scattering of light. So the re-emission, if you are taking this distance, okay, so the distance between two consecutive crusts, so the distance between two consecutive crusts or two consecutive trough is called wavelength. The distance between two consecutive crusts or two consecutive trough is called wavelength. Okay, na? So if you have any doubts, you can ask me. So if you like this video, please do like, share and subscribe my channel, YouTube channel, Student the Brand. Now you can check here. So I'm taking, so the distance between the consecutive crust, this is the crust and this is the trough. So this is the trough. So crust trough. So here also I'm taking crust trough. So the distance between two consecutive crust or two consecutive trough is called wavelength. is called wavelength. Is called wavelength. The distance between two consecutive crust or two consecutive trough is called wavelength. I'm considering wavelength. Okay. So if the whatever the light is coming, if it light is coming, so here is a particle. So this particle size is this particle size. So if you are taking this particle size is comparable to the wavelength of the light. So if I am taking much particle, so wavelength comparable to the wavelength of the light, then the particle will absorb the light. Then the particle will absorb the light and re-emit in all directions with a different intensity. So this light will be scattered. So in all directions with a different intensity. with all the so in all directions with a different intensity is called scattering of light. So in all directions with the intensity is called scattering of light. In all directions with the different intensity is called scattering of light. So when light here when light rays incident on the particle size is comparable to the wavelength of the light. Then the particle will absorb the light and re-emit in all directions with a different intensity is called scattering of light. Okay, so is it clear? Do you have any doubts? So scattering of light, sky appears blue color, sky appears reddish color, sky appears sometimes white. So because of all these reasons, because of scattering of light only. So next one, so you can see atmospheric refraction. Refraction takes place by the atmosphere is called atmospheric refraction. Refraction takes place by the atmosphere is called atmospheric refraction. So I hope it is clear to you all. Refraction takes place by the atmosphere is called atmospheric refraction. Okay. So here I am considering refraction takes place by the atmosphere is called atmospheric refraction. Okay. So now I am considering the refraction takes place by the atmosphere, I said. No? So do you have any doubts in this topic till now, whatever we discussed? If you have any doubts, you can let me know. If not, so we'll work out on remaining topic. Clear? So now I'm going to the here. This is the Earth. This is the Earth. Earth. So I'm taking the atmosphere. I'm taking the atmosphere. So here is origin. Here is origin. So here a sun comes. This is the sun. So I'm taking the sun. So light ray is coming like this. So whenever whenever light rays enters through atmosphere, so it's blend, it will bend. So I'm standing here. So it will come like this. So then the sun appears here. Okay, so because of atmospheric refraction, the sun appears here. So due to Earth atmosphere, so the refraction of takes place due to refraction of light. Due to refraction of light. Okay, so this is because of refraction of light. Next one, so I'm going to the Tyndall effect. Tyndall effect you can observe when you open in the morning. If you open the door, automatically sun rays will come. Sun rays will come. Sun rays will come. Okay, so that time we can observe a beam of light ray falls on it. The dust particles will fly off. Will fly in the dust particles will fly. So the path of the light becomes visible. The path of the light becomes visible. Shivani, actually, I completed human and colorful word. From generally, I'm going to the live. I'm teaching. So I hope it is end of the topic. So atmospheric refraction, I'm teaching. You didn't go to school today? Okay, anyway, I will teach. So this is a live class, and general. I said no. I will take remaining time also. That's why I'm teaching. I arrived already. Okay, okay, okay. So actually, still I can stay 20 minutes. So actually, 20 minutes stay class I'll take until 3 o'clock. I'll take. Then after that again 6 o'clock I'll take the class. Okay. So you wanted me? Do you have any doubts, or if you wanted me to explain the chapter, I will explain once again. Done. Thank you. So actually, I'll so end of the class now. I will teach once again. I will teach once again. So once the live class anyway 9 p.m. I'm taking class live class. So chapter is going on. Accordingly, I will teach. So now atmospheric refraction. Atmospheric refraction is completed. So atmospheric refraction means, so here you can see I am taking now here. So this is the earth. So sun is, this is the sun. Sun I am taking. Sun. Sun I am considering. So whenever the light ray comes through like this, so here atmosphere, this is the earth atmosphere, earth atmosphere, earth atmosphere. Okay, so this is the earth atmosphere. So this entire portion is earth atmosphere. Whenever the light ray comes from the sun, so because of the atmosphere, it will bend. So again we are taking here. So the position of the sun will be here. Due to refraction of light, due to atmospheric refraction, actually it is not refraction, it is atmospheric refraction. So refraction, only refraction takes place by the atmosphere. Refraction takes place by the atmosphere. That's why it is called atmospheric refraction. Atmospheric refraction. So the sun appears. See, this is very very important. 3 marks question will come. 3 marks question, very very important. So in exam point of view, it's very important. So surely this question will come. So 3 marks exam point of view, very very important. So make a note of it. So when see, this is the sun position. So earth atmosphere, the dotted lines is earth atmosphere. So this is the origin I am taking, origin origin. So when light ray is coming like this, so when it is enters through the atmosphere, so the refraction of takes place. Actually the position of the sun is here, but because of the atmospheric refraction, the sun appears here, the sun position appears here, sun position appears here. So due to what reason? Due to earth atmospheric refraction, earth atmospheric refraction. So this question comes very important. For 3 marks question will come. Okay, so advanced sunrise and delayed sunset. In the exam, they will ask about advanced sunrise. So the sun we see with our bare eyes from Earth is not actually in its original position. Correct. Actually, it is not in original position. So after, see, advanced sunrise, delayed sunset. So the question is there: advanced sunrise and delayed sunset means sun will appear 2 minutes before, and after 2 minutes still it will appear, because actually it will set means it will go, but still it appears because of atmospheric refraction, because of earth atmospheric refraction. Refraction takes place by the atmosphere. Even twinkling of stars also you can see. So here the sun is here, sorry, the star is here, sun is also star only. So you are taking like this. So here I'm taking the star here, I am standing here, one person. So here atmosphere will be there. Whenever the light ray is coming from the star, so there are many refraction takes place. Many refraction continuously takes place. But actually the star is here only. Actually the star is here only. So because of the continuous refraction, the star appear twinkling. The twinkling of effect of the star is takes place by the earth atmosphere. See, why planets do not twinkle? So only stars are twinkling. Why planets are not twinkling? Because so planets are minute point size sources. Point size sources. So if you are taking the Earth here, or planets, I'm considering one place. See, even though the planets doesn't have its own light, but it reflects the light. It reflects the light. So here one place it will be bright. So one place it will be dark. One place it will be bright. One place it will be dark. Like this, it will be there. So the total effect will be nullified. The total effect will be nullified. That's why we couldn't able to see the planets are twinkling. Okay, so planets does not twinkle. Okay, does not twinkle, because the overall effect of the light will be nullified, means cancel each other, like that. So becomes zero like that. So here the stars twinkle because of atmospheric refraction continuously. Then how do you astrophysicists study about stars? Because of this, they won't able to understand clearly, right? The periscopes, telescopes are there, right? telescopes here with our eyes it is blinking. Okay, so with our eyes it is blinking, right? But telescopes, so huge, so there are huge telescopes will be there. So they are that, with the help of the telescopes we can observe very closely beyond the atmospheric refraction. If you go, we can understand, we can identify stars, everything. Okay, so with the telescopes we can understand their positions, their revolutions. So revolution again, okay, so around the sun, around the planets, like that. So different, it is a our way, our galaxy is Milky Way galaxy, like us, like ours. There are many, are there many galaxies are there, there are many, plenty. So okay, so that's enough. So this is about atmospheric refraction. I hope it is clear. So this is very important. See, there is a one question related to planets and stars. There is one question, definitely a question will come. What is that question is, why planets twinkle, why stars are twinkle and planets do not twinkle. Simply, if they ask in a simple way, is why planets do not twinkle. So because planets are minute sources of light, means one place it will be bright, one place it will be dark. So overall effect will be nullified. So overall effect will be, cancel each other, comes to zero. That's why, so planets do not twinkle. Whereas stars, you see, stars light. So stars are illuminated object, means continuously gives the light. Okay, so continuously gives the light. That's why when light is coming from stars, so because of the atmospheric refraction, continuously the light will come, continuously the light will come because of the atmospheric refraction. So bending of the light takes place. Generally, if you are the two persons are there, one person A, one person B, so here middle fire is there. If you are seeing through the fire, so another side, the person image, it appears to be twinkling, it appears to be blinking, it appears to be flickering like that, like a wave motion it will be. So because of atmospheric refraction only it is happening, it is happening generally. So if you are considering, normally if you are considering, it will be okay. So normally we can see, so when you are weaving through that, hot air act as a rarer medium, cold air act as a denser medium. So when you are weaving through hot air, cold air, like that, if you are changing the lighter direction, automatically it appears to be flickering. So here, so that is a normal scale, minimum scale. So if you go for maximum scale, like stars twinkling, okay, so it is far from us. So that's why when keep on light comes and there are many refraction takes place, that's why it is keep on twinkling. So that is about related to atmospheric refraction and scattering of light. Next, Tyndall effect. The path of the light becomes visible when it is passing through the colloidal solution. Best example, lemon water can take. If you send the light, so at that, in that beaker, in that glass, the path of the light becomes visible because of the colloidal solution. The scattering of light takes place. What is the scattering of light? Re-emission of light in different directions with a different intensity. Best example, you can see water. Okay, deep sea appears blue color and sky appears blue color, and evening time, morning time and evening time, sun appears reddish color. So sun appears reddish color, sky appears blue color, and sometimes it appears white color, and the deep sea it appears blue color. So these all colors. So what is the reason behind this? Behind of this all colors means, so scattering of light definition, the re-emission of light in all directions with a different intensity is called scattering of light. So Tyndall effect we already discussed. When the path of the light becomes visible when it is passing through the colloidal solution. Colloidal solution is nothing but mixed solution. Okay, heterogeneous medium. So homogeneous medium means particle exhibit same nature. Heterogeneous medium means particle exhibit different nature. So colloidal solution means mixed solution. Heterogeneous solution, when light passes through the colloidal solution, so scattering of light takes place. Scattering of light is nothing but re-emission of light in different directions with a different intensity. Different directions means in all directions. So in all directions the light will spread. Okay, in all directions with a different intensity is called hey, hi, Naveen. Oh, thank you. So in different directions, it's called scattering of light, and Tyndall effect also completed. Then we can go to the next one. Tyndall effect over, scattering of light over. That's enough. That is about why stars are twinkle, why planets do not twinkle. So based on that also we discussed. So till now whatever I explained. I will recall all the points. So from morning onwards, I am taking live class. You can observe. So live class is available in the YouTube. So related to human in colorful world. So morning I explained eye parts and function. So parts cornea, iris, pupil, ciliary muscles, aqueous humor, vitreous humor, eye lens, retina, blind spot, optic nerve, all these points. So that is about eye parts and eye parts. So cornea is the most of the cornea is the front layer of the eye. Most of the refraction takes place at the cornea. And coming to the iris is a dark muscular diaphragm. It controls the size of the pupil. Pupil will control the amount of light entering into the eye. Pupil will control the amount of light entering into the eye. So next one, ciliary muscles. Ciliary muscles will adjust the focal length of the eye lens. So by that we can able to see near distance object as well as far distance object. Near distance object as well as far distance object, ciliary muscles. And eye lens, whatever the light ray falls on it, it converts the light rays and make it falls on retina. Retina is the light sensitive screen. Where image will form. That image will be converted and sent to the brain through optic nerve. So it like a electrical signals, electrical impulse. And next one, optic nerve. So it is through the optic nerve, the signal will reach to the brain. Actually here one point, normally we can able to see only 2D images. Whenever you are seeing the object, only we will get the 2D image. So the brain will add the additional information. Additional information is nothing but so we are seeing, see, a glass of water I'm considering. So here you can see like this. So this is a bottle. Okay, so if I'm seeing only 2D object, so that the image will form on the retina. So that convert into electrical signals and reach to the brain will add the additional information, that is how much depth it is, how much height it is, and how much depth the water is there, everything it will explain. Okay, so that our eyes will see 2D image. So whatever the image is formed on the retina is real and inverted image will form. So that will reach to the optic nerve, turns into electrical signal. Yes, image. So whatever the image is forming on the retina. So retina. Okay, here on the retina there are two light sensitive cells are there, rods and cones. Optic nerve will pass the signal. Okay, so optic nerve it won't pass. So that will convert in the form of electrical signal. Okay, whatever the image is forming on the retina, that will there the image. So at the retina itself, so that will then optic nerve will it is a signal carrier. It's a signal carrier. Okay, so whatever the image is forming there, it will convert into electrical impulse. So you can see in the movies, so when the person is hit on the head, automatically inside of the head the nerves are there. So it's like it flows like a electrical signal, electrical impulse. Yes or no? Electrical signal. Yes or no? Yes. So that through those are nerves, optic nerves. Through the optic nerves, the signal will reach to the brain. That is a signal carrier like that. So electrical signal like that. Okay. So next one we are going to the retina, there are two light sensitive cells are there, rods and cones. Rod sense the intensity of the light and cone sense the color of the light. So if more rods are there, we can able to see the during night time also. Oval can see night time. Okay, oval can see night time. So night vision it has. So automatically it can recognize the object. So even night time also they can hunt. They can catch the food. Okay. So like that, night vision. So oval has more rods. That's why they can see night, and like that. So cones can identify the color of the light. Okay. So next one, that is about human eye parts and function. Next one, myopia, hypermetropia, presbyopia. So myopia is nothing but the person can able to see near distance object. He can't able to see the far distance object. So for correction of myopia, we are using concave lens. For correction of myopia, we are using concave lens. For hypermetropia is nothing but the person can able to see far distance object. He can't able to see the near distance object. The person can able to see far distance object. He can't able to see near distance object. For the correction of hypermetropia, we are using convex lens. You can see. So this side is myopic. This is myopia. This is myopia, and this is hypermetropia. Okay, so I designed like this. So, and song also, the song of here I wrote. So song, here you can see this side is myopia, right side myopia, and the left side hypermetropia. I'm covering both the defects. So myopia nothing but the person can able to see near distance object. He can't able to see the far distance object. For the correction of myopia, we are using concave lens. For correction of hypermetropia, we are using convex lens. And here you can observe a few more points for causes of myopia. What are the causes of myopia? Here, excessive curvature of the eye lens. Focal length is less because the image will form in front of the retina only. And coming to the next one, hypermetropia causes of hypermetropia is eye lens become too small, focal length increases. That's why it forms at beyond the retina. Does myopia depend on genes too? It's not like that. So it is normally refractive defect. These are refractive defects. So it may or may not. Exactly, we cannot identify. But generally, it won't depend on genes. Myopia, it won't depend because these are refractive defects. Color blindness, night blindness. Okay, so deficiency of few members can't able to recognize the colors. Few members can't able to recognize the colors. Okay, so that is a color blindness. Sometimes people can't able to see beyond after 6 o'clock, after 7. That is night blindness. So this depends on genes. Myopia, hypermetropia, normally it won't depend on it. So it is a refractive defects. Refractive defects is nothing but here in our eye there is a convex lens. Here is a convex lens. There is a convex lens. By default, it is a convex lens. So whenever light ray falls, normally lens what it has to do, when light falls on it, it refract the light and make it fall at retina. But while aging, while growing up, okay, what happens? Some people can't able to the light ray can't able to refract properly. Okay, so lens does not perform properly. So that's why it is called refractive defect. There are 3 refractive defects according to our so few more are there. According to our textbook, mainly we'll discuss about myopia, hypermetropia, presbyopia. Myopia, so we can see near distance, we can't see far distance. Hypermetropia, we can see far, we can't see near. So that causes are very important. What lens we are using, that is very important. And coming to the next one, so we are going to the next presbyopia. The person who is getting older can't able to see near as well as far. For that correction of presbyopia, we are using bifocal lens. Upper portion is concave, lower portion is convex. So, and the next one, cataract. So when the person is getting older, so on the eye lens, so it will become milky and cloudy. So for by cataracts, by laser surgery only we can remove that cataract. So some people, it will be having milky and cloudy, white layer will be there on the eyelids. Okay, so they can't able to see the properly objects. Okay, so that's why what lens we are using? Bifocal lens. Upper portion is concave, lower portion is convex. And the next one, we can go for astigmatism. There is a defect astigmatism. So the person can't able to see the horizontal lines and vertical lines. He can't able to see the horizontal lines and vertical lines. For the correction of that one, suitable cylindrical lens we will use. And the next one, we'll go to the another one. This is about eye part. So next one, colorful phenomena. So light ray passes through the prism. Splitting of white light into 7 colors is known as dispersion. Splitting of white light into 7 colors is known as dispersion. So through the prism, light ray will pass. It's split into 7 colors. The splitting of white light into 7 colors is known as constant colors: violet, indigo, blue, green, yellow, orange, red. Violet, indigo, blue, green, yellow, orange, red with GR. So whenever light ray passes through the prism, split into 7 colors. The splitting of white light into 7 colors is known as dispersion. So after those colors, after passing through the prism, those 7 colors will form like a band. So you can see in the sky, the colors will form like a band. It's like a band. So there won't be any gap between the color to color. Okay, color to color. It's like a band it will form. So that, but band is called spectrum. That band is called spectrum. Okay. And next one, recombination of spectrum of white light. Recombination of spectrum of white light. So Newton placed prism, split into 7 colors. Again, he want to split the colors, so he placed normal prism, but still he didn't get. But he placed the inverted prism. So here like this. So I'm taking like this, and here. So he placed like this inverted prism. Here split into 7 colors. Then so then it will form. So again, by the inverted prism, so all these colors again will be combined, will get white light. So here white light, here also white light. So inverted prism, because of the inverted prism, so the colors will be combined and form like a white light. So that is about recombination of spectrum of white light. And coming to the next one, water droplet. When light passes through, each and every drop of water droplet act as a prism. Each and every tiny water droplet act as a prism. Whenever light ray passes, it's split into 7 colors. So what is the phenomenon involved in the formation of rainbow? Refraction, dispersion, internal reflection. Refraction, dispersion, internal reflection. Refraction, dispersion, internal reflection. When light ray passes through the water droplet, so it split into 7 colors. So what is the phenomenon involved in the formation of rainbow is refraction, dispersion, internal reflection. So that is about rainbow formation. Next one, will go to the scattering of light. The re-emission of light in different directions with a different intensity. The re-emission of light in different directions with a different intensity is called scattering of light. So scattering of light, where we can observe the scattering of light. So because of this, you can observe the sky color. So blue color. So evening time, morning time, it appears reddish color, and deep sea appears blue color. All these colors. So because of scattering of light only, all these colors will form. Next, advanced sunrise and delay sunset. So sun appears 2 minutes before and after sunset also, still we can able to see the sun. What is internal dispersion? Internal reflection. Actually here, I am considering like this. So water droplet, raindrop. This is a raindrop. Okay, so light ray passes. It split into 7 colors. Split into 7 colors like this. Okay, so this is white light. So 7 colors, violet and red. So this is violet and red. Here violet and red. So refraction, so bending of the light takes place. Dispersion takes place. Here dispersion takes place. Refraction, dispersion, and whatever the light is coming inside of the water droplet, so after incidenting here, again it will reflect back into the same medium. Okay, So that's why what is the phenomena involved in the formation of rainbow? Phenomena involved in the formation of rainbow is refraction, dispersion, internal reflection. So why we are taking only internal reflection? Why we are not taking total internal reflection? Why we are not taking TIR? Because total internal reflection, total internal reflection, total internal reflection, total internal reflection. Why we are not taking? Actually, it will makes more than 90 degrees. I hope in the light reflection and refraction topic there is internal reflection definition I explained. So if the light ray passing from this rarer medium, denser medium, light ray is passing. So this is the denser medium, water droplet. It completely water is there inside here. So if the light ray is passing from denser to rarer, if light ray makes more than critical angle, so more than critical angle, then the light ray will reflect back into the same medium, even though it is a transparent medium. So glass lab experiment, that only glass lab activity we discussed. No, even though it is a transparent medium, if the light ray passing from denser to rarer, so denser to rarer, if in the refracted ray, it makes more than 90 degrees. It makes more than 90 degrees. Here 90 plus theta, more than 90 degrees. Then this light ray reflect back into the same medium, so here only, so whenever the light ray is passing denser to again rarer, so it here in this case makes more than 90 degrees, then it reflect back into the same medium, then we'll get it. So here why we are not taking total light? So here some of the light will be absorbed by the water droplet because it's a transparent medium, some of the light may go out, some like this. So completely we cannot say. So total light is reflect back, but the total here internal reflection takes place. Because of internal reflection, so we can able to see the rainbow in the sky. So this is about refraction, dispersion, internal reflection completed, and scattering of light is also completed. Scattering of light is nothing but re-emission of light in different directions with the different intensities called scattering of light. And coming to the Tyndall effect, the path of the light becomes visible when it is passing through the colloidal solution, heterogeneous solution, mixed solution. So the particles of this medium exhibit different. So like that we can say. Next one we can go for, and why planets do not twinkle, and why stars are twinkle, why planets do not twinkle. 3 marks question in the chapter. So in human and colorful world, generally they will ask about parts. One if they ask for 1 mark, definitely parts function. So which one is responsible for image formation? Where image will form, what is the light sensitive screen name? Retina. And which light sensitive cells sense the intensity of the light? Intensity of the light means rods. Which light sensitive cells sense the color of the light? Cones. And if more cones and rods are present at one point in the retina, yellow spot, blind spot. So no lights reach to that point, though no light rays will intersect. So the dark place will be that is a blind spot. So it carry the signals to the brain. So and myopia, hypermetropia, definitely 5 marks question. 5 marks question will come. And coming to the next one, dispersion through prism, recombination of the light, and that question, and a prism question. And coming to the water droplet, 3 marks question. Water droplet also they ask for 3 marks question. And any other points missed? Water droplet, prism, Tyndall effect, and advanced sunrise and delayed sunset. That's enough. So that is about human and colorful world. I hope you are clear with that. If you like this video, please do like, share, and subscribe to Student in the Brand for further notifications, for further updates, further class. So this is our Shiva sir signing off. Namaste. Thank you, Shivani. So we'll see in 6 o'clock or 9 o'clock class.